Hey there, environmental science class. Hope everybody's doing good. Looks like this is kind of the final stretch here. Senior work is due May 8th, so this Friday, and then everybody else, your work is due on the 15th. So this Wednesday here, today, will be the final posting of any classwork. So you'll have a week and a half to get any of this done. And then, of course, the next couple weeks after that are going to be makeup work. So please get all your work turned into me, and we'll try and get you credit for your grades. So with that, this week, you'll have this review lecture on water resources. So it'd be wise to jot some things down and take some notes. I'll also post a review guide, and you'll be doing a final test. So that's going to be it, and look forward to seeing everybody kind of wrap this thing up. And as usual, let me know if you have any questions. So we'll go ahead and get started here. A little review on water resources and kind of what you should have taken away from the documentaries and the work you've done over the past couple weeks. So this slide is centered around some main topics that you guys have seen in the work that you've done over the past couple weeks, and the main topic being the Colorado River and how it once flowed consistently to the Gulf of California. Now it is kind of an every other year thing, depends on snowpack, but as you guys have seen through the work you've done over the past couple weeks in the documentaries, especially Chasing Water, it doesn't always reach the Gulf of California, and there are a lot of uses of the Colorado River, a lot of dams on the river, a lot of states that draw water from the river, and there are also some ways that are coming around for conservation of the river. You saw Las Vegas is doing a lot of things to mitigate water use, but they still got a long ways to go. So this slideshow corresponds with the sections of the water resources chapter in your textbook, and the diagrams in this slideshow are the ones that are exactly out of your textbook. So that's kind of why it's going to be broken up into a couple different lessons. This being the water planet, we'll go through a few slides here, and just the information posted on this one. Although the vast majority of Earth is covered in water, 1 in 8 people lack access to clean, fresh water. So, although there's a lot of water on planet Earth, what happens to that water? Well, fresh water is a renewable resource, but it is also limited. So, if that resource is used faster than it can be replenished, then it can turn into a non-renewable resource. So water is considered renewable. You should be familiar with the water cycle, kind of gone through that a little bit. But Earth's water is distributed unequally. So as we've been going through, we know that there are different uses for water. Different areas need more water than others. So it's pretty hard to allocate who gets what a lot of times. Looking at some terminology, you need to know what surface water is. You also need to know what watersheds are. So surface water includes all the bodies of water that are on the surface, right? So on Earth's surface, and that's going to include still bodies of water such as ponds, lakes, and then also rivers. So river systems, streams, and creeks are also within surface water. And then watersheds include all the land area that supplies water to a river system. So that's when we're looking at those extensions, those tributaries of water in creeks and streams that come into the rivers. And again, that's going to be the watershed. And so every waterway defines a watershed. And something else that's not always mentioned when we talk about surface water, and it's kind of pushed aside because not a lot of people know a bunch about these areas, but wetland areas also carry a lot of surface water. Wetland areas are very important ecologically for habitat and for water storage. And if you take further environmental science and biology classes, you'll hopefully learn more about wetlands. Another term you need to be familiar with is groundwater. So groundwater is a very important resource, especially in a lot of areas that could be dry and that don't receive a lot of water. But those that do receive a lot of water We'll also have a pretty high water table. A lot of farmers in the Midwest rely on groundwater. There's aquifers throughout the Midwest. In fact, the largest aquifer in the United States is in the Midwestern area of the U.S., Kansas, Missouri, Nebraska, on up into the Dakotas and down into Texas and Oklahoma. It is the Ogallala Aquifer, so you'll probably come across that in the future as well. These aquifers are made of groundwater, so that groundwater seeps through the soil and becomes contained in those underground areas. And aquifers are layered with different types of rock, usually impermeable rock underneath and semi-permeable to permeable rock above. Permeable means that there's enough spaces for that water to seep into, and then when it reaches that bedrock or impermeable layer at the bottom, it will sit on top of that layer. Then the water table separates the zone of saturation from the zone of aeration. Again, wetlands are an important part of this as well. Wetlands will have groundwater areas or be a part of groundwater areas. They will have a high water table, and then that will have the surface water, and then underneath that water will soak into the groundwater as well. Last little bit of information on groundwater here is that aquifers will release about 492 billion gallons of groundwater to the surface each day through springs, geysers, and wells. So the picture over here on the right is that of Old Faithful and Yellowstone National Park. Pretty cool geothermal area, geologic area that is very active with springs and geysers, so that groundwater is active in the cycle. If you ever get a chance to go see any of that, it's pretty spectacular. Moving on to section 2 here of this lecture, we'll look at uses of freshwater. As mentioned earlier, 1 in 8 people do not have access to adequate fresh water, and 1/3 of all people on Earth are affected by water shortages in some way or another. Freshwater is used in many different ways, but the 3 main uses of freshwater include agricultural use, industrial use, and personal or domestic use. So within the house, whether it's for washing clothes, washing fruits and vegetables and other foods, brushing your teeth, flushing the toilet, those are all domestic uses. As far as using surface water, most fresh water used in the U.S. is surface water. That surface water can be diverted by a variety of structures, mostly by canals and dams. You guys saw or heard about diversions, especially up near the Continental Divide, that actually diverts snow melt from the western part of the state to the eastern part of the state here in Colorado. And then you guys saw extensively the past couple weeks how drought and overuse have caused significant surface water depletion with the case study of the Colorado River. And then there's a lot of reservoirs and lakes that also fall into that category as well. I talked a little bit about groundwater earlier as well, and groundwater is used quite a bit, especially in the Midwestern states for farming. It's used as an irrigation source, so that groundwater is pumped up to the surface, and it is, again, used as irrigation, so through sprinkler systems on crops throughout the Midwest. Groundwater mining turns groundwater actually into a non-renewable resource because that resource, the water itself, is actually being pumped faster than it can be replenished. So when that groundwater is depleted, the falling water tables will cause, as the picture shows here on the right, cities to sink because the ground where the water was is now unstable and it could collapse, and then undrinkable salt water to move into the depleted aquifers. Sometimes if they don't collapse, especially in coastal areas where there is salt water, and then that will not be usable for drinking or for watering crops either. Some more terms to be familiar with here, especially when we're looking at solutions to freshwater depletion. If we're looking to increase supply, desalination is a process that could make fresh water by removing salt from the seawater. There's a diagram over here on the right that talks about desalination. It's really as simple as boiling water. Distilled or deionized water is kind of the same idea, where all the ions are removed from water through boiling. That salt will be left behind and the water itself will turn to vapor. It is collected in a chamber, cooled, and then condensed, and it is pure fresh water. This takes an extraordinary amount of energy. As you can see, the diagram there on the right has a heat source, and it would be working constantly. So it would provide quite a bit of fresh water, but maybe not so sustainable in that it takes a lot of energy and it essentially costs a lot of money too. So decreasing in demand as far as uses of freshwater, agricultural freshwater use is through drip irrigation, and that can only happen in climate appropriate areas where plants are able to use that water. Industrial uses include water conserving processes. We could recycle wastewater to cool machinery. And then they talked about xeriscaping in Las Vegas on the documentaries that you watched, and this is also a type of water conservation as well. All right, last little section here on water resources. We'll take a look real quick at water pollution. Just a little fact on this slide as well. 3,800 children die every day from diseases associated with unsafe drinking water. A little bit more terminology that you need to be aware of, and that is the idea of point source pollution and non-point source pollution. These two types of water pollution are a little bit different, sometimes hard to try and figure out which is which. Point source pollution you can think of comes from an exact point, so maybe a pipe from a factory or a sewer pipe of some kind. Automobile exhaust comes exactly from a pipe, so it's a specific point that can actually be located where that substance comes from. And then non-point source pollution is going to be pollution or substances that are spread over a wide area. So you can think of fertilizer on a field that may run off into water. You may think of motor oil on a roadway or gasoline on a roadway that kind of seeps into water sources. Maybe it eventually ends up in pipes, storm drains or whatever that can flow into waterways. Or could be methane from different areas. Landfills exert a lot of gases from decomposition, so that can be an example of non-point source pollution as well. So I just mentioned fertilizers as an example of non-point source pollution that can be applied on agricultural fields. If that fertilizer happens to run off to a water source or seep into the groundwater, it can cause excess nutrient loads, and that may lead to the process of eutrophication, especially in slow-moving bodies of water or still bodies of water like lakes and ponds. What happens is the nutrients will build up in that water, and algae will feed off of those nutrients and grow. The algae will take in oxygen from the water, and those organisms will not be able to survive. So what we have are dead zones. There's large dead zones in the Gulf of Mexico where the Mississippi River runs into the Gulf. And this is because the Mississippi runs right through the heartland of agriculture in America and obtains all of those nutrients. So these dead zones are going to be zones that cannot sustain aquatic life. There, again, is a lot of algal growth, and then decomposition of those organisms will take that oxygen and not allow others to survive in that area. Toxic chemical pollution can occur in a few different ways. This happens when harmful chemicals are released into the waterways. and these chemicals can be organic or inorganic and will ultimately harm ecosystem health and can lead to human health problems as well. These types of pollution aren't often thought of, at least right off the top of everyone's head. Sediment and thermal pollution are two types that are very prevalent. Sediment pollution is just that, where sediment may run off into waterways and this increases sediment load. A lot of aquatic organisms have a hard time surviving in high sediment loads, and we really see this around uh, our waterways in the spring, especially during runoff when the snow melts. And it just depends on how fast the snow melts. If it melts rapidly and increases sediment load, that can be harmful for aquatic organisms. It can also clog up a lot of filtration systems and leads to flooding as well. But if you look at landscapes that have been degraded by humans, this also leads to large sediment loads that can end up in our waterways and create a lot of problems. Thermal pollution is when temperature of the waterway usually increases. Heated water holds less oxygen, so when a heat source will raise the temperature of a waterway, that is also a bad deal a lot of times for aquatic organisms, and they can't survive or can't tolerate the higher temperatures, and then of course there's not going to be as much oxygen available in this case. Biological pollution is kind of a nasty thing to think about. Usually, this type of pollution occurs in the form of pathogens and how pathogens will enter a waterway. A lot of the times, those pathogens hitch a ride on feces, so it could be human waste, could be livestock, could be wildlife waste. This pollution causes more human health problems than any other form of water pollution, as you can imagine, and water treatment is usually one of the ways to reduce biological pollution. A lot more times than not, again, those third world countries that struggle with sanitation issues will have more biological pollution than other places, but the little box down here with the did you know question is pretty spot on, and you've probably heard of Giardia before, but this is going to be the most common form of waterborne disease, and again, usually hitches a ride on feces that are near waterways and then end up being washed into that waterway. So don't drink the water unless you know for sure it's coming from a reliable ground source or has been filtered in one way or another. Coming back to groundwater and the idea of groundwater pollution and how groundwater can be polluted. Again, those sources of groundwater can be subject to what is known as leaching. So landfills are kind of notorious for this. If there's not good lining underneath the landfills, or if you don't have a packed sediment like a clay layer that will trap that leachate or liquid juice that forms, can be in this can be formed from a lot of different ways. A lot of times when it rains or snow melt ends up in these landfills or different areas such as mining areas. You can see that picture on the right. That liquid will pool up and it has all of this trash juice or whatever you want to call it in a puddle, and it can soak into the ground. And again, if there's not appropriate lining or if there's not appropriate clay materials underneath to prevent that liquid from soaking into the groundwater, it could cause a lot of problems. So some chemicals break down more slowly in groundwater than in surface water, and most efforts to reduce groundwater pollution focus on prevention. Again, appropriate lining or disposing of waste properly is the best way to prevent this problem. As far as ocean water pollution goes, petroleum products are one of the main types of pollution that oceans have to deal with. So that oil pollution in the ocean comes from many widely spread small sources. We can have seeps and leaks. There's spills from oil tankers, pipelines along the coast will spill and leak. Industrial factories along the coast will also add pollution to the ocean water. So Like I say, it's a lot of um, petroleum products, but ocean organisms will actually bioaccumulate a lot of this pollution. And what that means is the smallest organisms in the ocean will accumulate pollution. And this example on the slide is talking about mercury. So from textile plants, whenever waste maybe leaks into the ocean, a lot of those textile plants and factories produce mercury as a byproduct, and not a lot at the source, but when you have a bunch of factories lined up, say on the coast, and each factory puts a little bit of their pollution into the water, it will accumulate, right? That magnifies. So the small organisms are exposed, and then the larger organisms eat the small organisms, and then the bigger ones eat the uh, ones that have eaten the small organisms, and it just kind of compounds from one level to another. And that's why a lot of times tuna come with mercury warnings. Pregnant women are not supposed to be exposed to seafood because of these mercury warnings. So there's just different levels of bioaccumulation, and there's a lot of other examples that go with this too. But then the last part here, nutrient pollution can cause red tides. So red tides can be an algal growth or a type of microorganism growth that produce toxins, and those red tides are dangerous to other aquatic organisms. They can be dangerous to humans. And those of you that are college sports fans know that the University of Alabama, their mascot is the Crimson Tide, and that's exactly where this comes from. Is the idea of these red tides, where these microorganisms are blooming because of excess nutrient load, and they produce a toxin that is deadly to other aquatic organisms. All right, last couple slides here, and they're going to be dedicated to some solutions and how water pollution is controlled. There's a lot of regulation, and there could be more. It could be better. It's very political on how water is used and who gets to use it. And that really goes back to just how many people are on planet Earth and how we can divvy it up evenly. And I'll just tell you right now, it's not even. So that's a big issue. So the government has kind of stepped in, and they try to regulate water pollution. They also try to regulate who gets what water and where it goes and how it's used. So the Clean Water Act is an example that set water pollution standards. It requires permits to release point source pollution. So these big factories and really the oil and gas industry has to apply for a lot of permits and jump through a lot of hoops to get rid of their wastes. And then sewage treatment plants can be constructed in a lot of different areas to try and clean biological pollution as well. Last slide here is just going through water treatment and kind of what I mentioned on the last slide about biological pollution. So drinking water is treated to remove pollutants before humans consume it. Wastewater is treated to remove pollutants before human used water is released back into the environment. So there's a variety of steps, as you can see on the diagram, where sewage enters a system through the inlet pipe, and this is kind of a septic system idea. Underground, where again that sewage enters, and then solids will sink to the bottom of the tank, and it can eventually be pumped or cleaned out in one way or another. So less dense waste that break down slowly build up at the top, and again that can also be pumped out or skimmed, and then water and wastes that have broken down travel to a gravel field through an outlet pipe, and that gravel will actually act as a filter and scrape off a lot of the microorganisms as the water kind of seeps and infiltrates through that rock. So those microorganisms and other biological waste products will be attached to the rock, and then that clean water will eventually flow into those areas. So again, this is a septic system, and it's one of the most popular methods of wastewater disposal in rural areas. And again, that can be kind of cleaned out. So if you have a septic system, I would encourage you kind of maybe learn a little bit more on how that works. This is just kind of one way. I'm sure there's a bunch of different ways that septic system work, but this is kind of, again, one way that happens in the general idea. So, all right, that's it. This is the last little bit of information that you're going to get for this class for the year. So good luck to everybody finishing up here in the next few weeks. And again, if you have any questions about anything, please let me know.